create a new animated blueprint. It is very important that the class is to be inherited from Anim multi-node instance _dn. You also need to select the appropriate skeleton. In Anim graph you need to create only one node, called DynamicNode. That's all. Open the character's blueprint, select Mesh, and in the Anim class section, select the newly created animated blueprint. For a quick start, we'll start with the creation of the event tick. Then we need to create the animations stack function. This will essentially be a container for our animations. Further, using the animations output we'll create two more functions, jump machine and move machine. At this stage, we will not go into details, we'll just select the desired animations. For jump machine these will be the start of the jump, the falling loop, and also the landing animation. For move machine, we need to enter at least two animations. These are idle, as well as movement animation. The other options will be discussed later. Done. Let's check the result. Let's discuss move machine in more detail. Idle asset is pose notify is the name of notify for idle animation. If we enter a value into this field, the idle animation stops playing and freezes only on this notify. This parameter is used for the very specific needs. As you can see, the character froze in a particular chosen pose. Transition time. This is a group of parameters that is responsible for the speed of transition to these animations. From any other, I will show by the example of idle. Max walk speed. This parameter defines the border between quiet movement and running. It is necessary to understand which animation to choose in this context. It should be a little greater than the value set in the character movement. Next, the group of parameters drop play rate. These parameters are needed to slow down a play rate when the character's speed is low. This creates a smoother transition. It's possible to adjust the coefficient here, as well as the minimum threshold. Impact handle. This is a parameter which is needed in order not to let the movement animation play at all, when the speed is very low, so that there is no running into the wall in place. It's important not to overdo with this parameter. To the inputs move and run we could also enter blend space. Let's create the blend space 1D. One single axis should be considered as speed, it should correspond to the character's movement speed. Blend value for speed will be calculated automatically, nothing needs to be programmed. Let's select the desired movement animations. The only thing is that there should not be the idle animation. There is a corresponding input for it, discussed earlier. In the sample interpolation section, set a new value for a smoother transition between animations. Let's select the newly created blend space. Done. There is also support for blend space 2D assets. Let's create it. The horizontal axis should account for the direction. The vertical we should account for the movement speed. We have 4 animations, moving forward, left, right, and also backward. Let's set the animation back for 180-degree angles too, since in fact, at such angles, the character runs backwards. For 90-degree angles, set the animation left and right, depending on the sign of the angle. Select blend space for the move animation parameter. It's also needed to tick the use controller rotation yawn class defaults. Let's check it out. All vectors are calculated automatically. For more complex cases, when the direction needs to be set in a custom way, we should call the setCustomsDirection function. This function needs to be called before move machine and update each frame. There are 2 ways to set up the running animation. There's possibility to select the same asset as for move, but by a slight increasing play rate. Let's create the running function for the left control key. This is done simply by increasing max walking speed. You can also choose a special animation for running. But here we can see a small problem. Move Machine is built in such a way as to make the transition between animations instantly, without completing the previous one. There is a solution to this problem. It is the Move Machine Multi. It always completes the previous animation in transition. But as we can see, the transition is still not smooth enough. To make it perfectly smooth, we need to enable synchronization, and also adjust it in the corresponding assets. This is done by adding synchronization marks to the left and right leg separately. These marks should be affixed to all assets, from which the transition is possible. In this example, it is set to only 2 assets, but there may be more of them with a structure complication. There are also Move Machine Extend functions. These functions are extended by the fact that there is an input for the movement start animation. In the ideal case, it should smoothly transfer from idle to move. As well as the parameter for the movement and animation, it should smoothly transfer from move to idle. The parameter start-stopping coefficient determines at which moment of the movement stop the end move animation should be applied. If it is 1, then the animation will be applied immediately after the start of the stop. If it is 0.5, then only at a speed which is equal to half of the maximum. Multi-version differs only by the presence of synchronization. I would also like to mention a bug that often occurs when the max walk speed field is exactly equal to the value of the move component field. This occurs for the reason that the move machine cannot determine whether a fast running has already started or not. For this reason, it's better to set the value of this parameter a bit greater than the max walk speed. The plugin also contains a function for work with a slope surface. The function has three exe outputs, which determine when the surface slope goes upwards, downwards. When there is no slope at all, there's also one float output, which determines the degree of the slope intensity. For exe outputs, the move machine normal or multi option for proper synchronization could be used. Let's go through the function parameters. Min time on slope to play. How much time needs to be spent on the slope to start playing a special animation. Raytrace normal, which should be the z component of the normal to the surface. This parameter is needed to weed out even flat surfaces on the basis of kinda stairs and ledges. These normals are usually close to 1. To weed out these surfaces, it is enough to enter a value close to 1, for example 0.95. Slope up threshold in and out options. These parameters are needed to determine when the upward slope began and ended. They express the slope intensity. The same refers to the slope down. Min time to play. Minimum time for playing slope animations. It's necessary so that the animations are not interrupted very quickly. Change slope dir. This parameter is similar to the previous one, but it is used when the slope type changes. Ray distance. Distance between the front and rear raytrace. Height factor. Raytrace height index. Use 4 arrays. Use 4 beams instead of 2, as well as the width of additional beams. Update rate. The higher the parameter, the less update and more performance. For example, I set up a special animation only for slope up. For greater realism, the maximum speed of movement on the ascent could be reduced. Let me remind you once again that for the best synchronization of animations it is better to use Move Machine Multi, where the necessary marks are set for each animation. Here I show how using Raytrace Normal you can avoid slope processing being on the stairs. Let's now analyze the transition zones. Let's start with the creation of such a zone. Let's place it at the ladder for example. Zone type, the parameter is needed to determine which particular zone it is. Priority, needed for inserted zones. When one is inserted in another, we define exactly which one is to be used. The following two parameters determine when to start playing special animation, as well as how much time it takes to play. Now in the event graph we need to create a special function. It has two outputs that determine whether we are in the zone or not, taking into account the parameters set earlier. You need to enter the zone type, as well as the function identifier. This query ID must be unique for each such function within the code of this character. An error has occurred. It's necessary not to forget to put a tick in the animation stack. That means that there will occur the processing of zones in this stack. The plugin also supports processing of collisions with obstacles. You can set a special animation, the impulse throwing from the wall, and even redefine the impulse feed direction. Let's create a notify for the animation to shorten it a bit. If the movement component from the DynamicNode is used, you can make a reparent blueprint for a standard character. Then you can configure additional parameters for processing collisions. Let's select character movement, searching by the word impact. There are two parameters, at what minimum speed the processing will occur, and also which the maximum angle can be. One means that the angle should be only straight. The less is the value, the greater is the angle tolerance. Chance set, a special class that allows adding variations to animation assets being played. Let's create two in the begin play event. While creating this type of asset there are a number of parameters. We need to select the desired animation, as well as the chance of its appearance. One option from the list should be selected as default. Can change in runtime determines whether the animation can be changed during its playback, otherwise the animation change is possible only with its new start. There is a special timer for changing the animation during the playback. You can also set it to work only once. This allows almost 100% of the animation change after its expiration. Pause between choices is needed for optimization. Let's see how it works. As we can see, for the reason that we have not installed can change in runtime, the animation update only comes after its new start. Let's try a bit differently. Now we can see that the change of animation takes place during the playing of the old one. Let's try to disable use pause only once. Animations now began to be changed less predictably and longer. Let's create one more. This time, for the move animation. We can also link these assets using the setParentAsset function. The derived asset will always repeat the choice of the parent one. Let's set idle as the parent for move. In the end the movement animation will follow the idle. Use parent data only once. This parameter allows the derived to follow the parent only at the moment of the start, then during the playback of the derived animation, it can be changed to any other from the list, if of course the value and can change in runtime is true. In the chance set class there is a number of functions that allow you to add a little bit of the manual control. Set next index allows manual selection of the next index from the fetch, despite the chance level. Let's set the value -1 as a flag, indicating that there is currently no manual control. Now when we press the left control button, we manually change the animation. Variation set, very similar to the previous one, but designed for a little bit different purposes. It allows adjusting the repeat parameter for each of the animations to repeat it as many times as necessary, before changing to the next one in the list. This kind of variation works only during the start of the animation. It cannot change the animation during playback. It may also contain null animations. It's also important not to forget to enable iterating enable, otherwise there will be only manual control. Manual control is possible through the setCurrentIndex function. It's also possible to customize the parent. Let's create another variation set for move. Call the addLinkedAsset function. It will connect these assets, and in all the linked assets there will be called the same index as by the parent. Often there's a situation that there's only one jump animation, instead of 3. To fix this situation there's a special class in the plugin. Let's create it. Select the jump animation itself, and also create a notify where we want to make a loop. Transition time. This parameter indicates the transition time between notify to create a loop. Start looping delta time. This parameter is needed to delay the start of the loop for the first time while doing transition to this asset. This is needed to create a smoother transition. Let's substitute this asset into the following loop, and also assign the desired notify. In fact, we use this asset 3 times. The first time we play it before the loop start, after loop we play it from the position of notify which signals the end of the loop. Very quickly, let's slow down the play rate. Instead of using the usual jump machine specifically for this type, there is a function jump machine simple, which has only one input for the animation and fills all notify automatically. There is another kind of jump function, jump machine next. This is an extended version, which also allows setting animations for a long jump when a character falls too fast. The speed limit for determining this state can be entered as a parameter. It's also possible to use only z component of speed. We can also set the preluded animation when the character is still in the air, but is about to land, It's possible to set the desired height and optionally the speed of the fall. We'll talk more detailed about this type later. During the jump, it's also possible to set a special type of animation for air control. It will work only after the end of the start jump animation playback. So, the start jump animation could be shortened a bit. There are several functions in the character movement that allow better adjusting the air control. Now I will increase its intensity a little bit. There is also support for crouch animations in the plugin. Now I'll set up crouch status for the left control button. In the character movement, it's also important to enable can crouch. Let's create crouch machine. It has 3 inputs for animations: start crouch, crouch idle, standing. But it is enough to enter only one, either start crouch or crouch idle. Also, instead of standing, start crouch in reverse can play. Now we need to enter movement animations in this status. This is done by adding move machine through the output of onMoved. It's enough to enter only one movement animation there, although it's certainly possible to make a sprint in this status. The transition time quick return parameter sets the time of the blend, in walking, in case of a quick exit from this status, without using standing animation. In order to correct the camera jumping effect, the camera boom should be set up as the inheritable from mesh, not from capsule. Let's set up the flying feature. Let's use the function from the DN character. If your class is not its successor, you can make a reparent blueprint. When returning from flying, you need to deploy a character. Save only the yaw component. To make it turn more smoothly, we will use a special function from the plugin. Now we need to change the movement input for the flying mode. At the moment we take only the yaw component from the control rotation. We need to take all the components completely, if we are in the flying mode. For a C++ based project, the following lines should be inserted. The last thing you can do in class defaults is to put a tick for use controller rotation only when moved. In this case, the character will be rotated only while moving. Let's create Fly Machine. It is similar to Crouch Machine with a few differences. The most important difference is that when moving in flying mode, there is an opportunity to set more animations. For mech, the output is triggered only when we press the acceleration button. From vel, the output is triggered only when there is no acceleration already, but there is still speed. The character has not completely stopped. In order for the from vel output to be available, you need to uncheck it. It's also possible to configure the threshold at what speed the idle animation is to be used. Now let's go swimming. In the first place, let's create a reservoir. As the material of water, you can use the material from the plugin. It's provided as a bonus. Do not forget to put effects on high level and higher. We also need to completely remove the collision. Let's create a physics volume. It should be placed exactly on the surface of the water. Let's make the z-coordinate the same with the water plane. Now to align them we need to add half the height to the z-coordinate. For 200 halves equals 400. Do not forget to tick the water volume. Let's also create a post process, align it with the physics volume. As a post-process material, we can use a bonus post-process underwater material, as well as we reduce blend radius a bit. As for flying, we need to set up the specific movement input, but this time we need to take the yaw and pitch components. For C++, similarly, copy these highlighted lines to your code. It's time to create Swim Machine. This feature is more difficult than all the others, but it has very great features. Firstly, 2 idle inputs for animations, one for underwater, one for swimming surface. Let's fill in only these 2 positions. Secondly, at the onMoved output we can configure up to 5 different movements. For the time being, let's only adjust the acceleration outputs, for underwater and for the swimming surface. Let me remind you that it's also possible to use any kind of move machine here. Now let's configure the behavior when exiting the swimming mode. We did the same for fly machine. Remove the unnecessary rotation inputs. The character can swim on the surface and underwater. We need to set up the max walk speed for movements underwater correctly, because the speed is completely different there. I would also recommend to increase the min drop rate setting. The plugin also allows analyzing when we are in shallow water walking. It's necessary to set up the immersion depth correctly for this mode. A value of 0.25 means that the character will enter this mode when he is immersed in water for a quarter. When immersing for more than 0.5 he will already be swimming. We can also configure that when the character is in shallow water walking its maximum speed is reduced, but since the speed in water is to be reduced smoothly, there's a special function in the plugin. When exiting this mode, the maximum speed should be returned to the previous level. Now let's set up the animation at the start of swimming, as well as at the end of swimming. Here the jump animation is perfect. You can also set up an animation for jump out of water, if the corresponding option is included in the character movement. The plugin allows customizing animations for jumps into the water. For this purpose we'll create a variation set. Let's disable the possibility of auto-iteration, and choose one animation, jump into the water. The setting for another is null. We need jump machine next. Let's copy the basic animations with the usual jump machine. From the preloaded output, we will call a function to determine the depth of the water. Enter the desired value. And if this function returns success, then we will set that index in the variation set, in which we set the animation of the jump into the water. While fail, we will select the index where we had null. Remember to set the pre-landed height to a sufficient value. Add playsec. When entering the water, how long in seconds to continue playing the animation of the jump into water. As you can see, there is a very sharp transition between animations. It occurs due to the fact that when jumping into the water, the speed reaches the run limit. In order to smooth it out, you need to increase the transition time run parameter. Also, while in the water, the rotation rate should be changed to smoother values. Go to the character movement. There is a number of parameters associated with jump out of water. You can change the speed of the jump and at what maximum depth it is possible at all. And you can also make the speed of the jump depend on the current depth. The deeper the character is immersed, the slower it jumps. Next are the parameters for surface swimming. You can change the speed of swimming. At what depths it will swim. You can also set the threshold for the falling speed. If the character exceeds this speed, he will immediately go into the underwater swimming mode. Then there are two parameters that determine whether the character will switch to surface swimming mode when surfacing, or remain underwater. Now I have set the vector to a value close to 1, and in order to surface the acceleration should be directed almost vertically. Another parameter determines how we will be diving. You can set the acceleration vector to a greater value. In this case, the character carries out diving only at a steep downward angle of the camera. Or you can use the dive function. Besides it, there is also surface. Next are the parameters for the waves, so that the character oscillates a little in the water. There is a speed limit, as well as friction parameters. The surface swimming parameter in Swim Machine is redefined by character movement. It's used only if it's not ticked. Out of water dash the parameter that determines, while in the water, at what depth the character leaves the swimming mode when jumping out of the water. Shallow water, at what depth the character will enter the appropriate mode. The plugin also supports other types of machine. For example, there is a function that can be used for movements while lying. But here the status should be set manually for every frame. All these extra functions are very similar to Crouch Machine. There is also a function for the mode, sit, although you can simply use play animation, which will be discussed later. There is also a custom machine. The maximum value is 5, that is, the index can be from 0 to 4. It also matters where exactly you insert these state functions, since they overlap each other during operation. Let's now consider branching as a way to diversify a set of states. Suppose we want to make an additional flying mode. In this case, when using this mode, we simply organize the second flying machine using the branch function. Using this method you can make a set of states of any complexity. Let's consider now how to use turn animations. For a better setting of turn animations, take the Use Controller Yaw checkbox in the Class Defaults tab for a while. Also temporarily, for setting, reset the following parameters. As we can see from the first animation, the transition was more ragged than from the second one. To correct such situations, there is the blend speed in parameter. It's also possible to adjust the blend speed out. Change Anim speed is the speed of the transition between turn animations. For example, we started turning to the right and then abruptly began turning to the left. Fast factor is a multiplier for blend speed out when you need to quickly complete a blend, for example, when we started moving at a speed exceeding the speed limit. Using the adaptive play rate, you can achieve the effect of increasing the animation speed when we turn back quickly, and vice versa. Adaptive play end does not start a new cycle of the animation if we have almost reached the end of the turn. Turn animations can be customized for the respective assets, and apply them only to these ones. If you remember, earlier we changed the blend speed in parameter. I returned the value 11 to it for the second asset. You also need to remember to enter not only the idle asset, but also the move, since the character begins its turn with the idle asset, and ends with the move. Let's now remove the Use Controller Yaw. We can see the character blink on the first asset by the movement start. This is due to the fact that fast factor is too big. On the second asset, everything is okay. This is due to the fact that the turn and movement animations almost coincide. Much better now. The min angle rotation threshold parameter is needed in order not to use the turn animation at a too small angle of turn. The one frame parameter is the same only in terms of one frame. In the character movement there is the parameter rotation rate. It also needs to be taken into account. We will make it less, so that we can better see the work of the turn animations. There is also a function using which you can make turn animations to be applied only to selected assets, and nowhere else. As we can see on the first asset, there is no more turn animation. Go to Character Movement and turn on Use Controller Desired Rotation Specified Angle. In this mode, a character starts to turn in place only when it reaches a certain angle and at a given speed. There are special functions that allow setting the turn-in-place animations for this mode. Let's reduce the blending speed a bit, and also increase the play rate, which is not adaptive in this function. Now I will clearly show what the last parameter is for. As we can see, at the end of the turn the animation started again, and as a result, the character kicked a bit with his left foot. To avoid this effect, we need the last parameter. As well as for turn in place, it's also possible to set all turn in place animations for different assets. Do not forget the move asset. This parameter indicates what kind, turn or turn in place, to use during the start of the movement. If the angle is greater than the specified one, then turn in place animations will be applied. In this case, here it's also possible to make the turn-in-place animation be used only for certain assets and nowhere else. Now I will disable turn-in-place animation for all assets except one. It's also possible to turn off all turn assets altogether. Now I will explain how to work with sockets. Firstly, let's create a socket on the right hand. It will be used for the sword. Let's add a preview asset, but don't do anything with it yet. Let's also add a socket for pelvis. Now open Equip animation. As we can see, the information about the sockets has not been updated. You need a tab and open it again. Now everything is okay. It is in the animation that we will now correct the position and orientation of our created sockets. Don't forget that the Details panel also has tools for turning, but they do it in relative coordinates. Now let's correct the pelvis socket. It should correspond approximately to that position when Equip moment occurs in the animation. although a slight deviation is permissible. Let's add the sword to the scene. Do not forget to set mobility on the movable, and also disable the collision. Later I'll explain how to save the block all collision. Create a variable for the sword, actor type. Now I will show how to attach sword to the pelvis socket as quickly as possible. A little bit later I'll explain how to make the same thing more smoothly, using animation. For simplicity, I'll just set up a sword link in a character, although it would be more correctly to use box trigger for this purpose. Now let's create the equip function. It is needed to equip our sword into the hand. Let's create a delegate firstly. This is a callback function that gives a signal when equip is complete. Next you need to create an equip data. This parameter is an array type. This is done so that you can equip several hands at once. Notify to action. This parameter says where exactly in the animation we will make equip for this hand. You also need to specify to which particular hand socket we will attach this sword. We can't change the collision preset during equip. This is necessary when the initial preset was block all. If you want equip animation to completely replace all current animations, then you need to set the stack priority value greater than the current one. Using a big equip value, the animation replaces all other animation stack if their priority number is lower. If you want the animation to play only for the upper body, and for the lower body the current animation from the event tick is used, then you need to set the bone name parameter, and to set the stack priority value equal to the current stack number. If you set the transform time parameter, then the transformation with Equip doesn't happen instantly, but over time. It's also possible to reduce the play rate during this transformation. Note that now callback was called for 2 times, to start the transformation and when it's finished. Now I'll explain how to make the grab animation using the same scheme. You just need to change the animation itself, as well as notify to action in it. Now use the grab collision profile name parameter to change the type of collision during grab. If this is not done, then the character will not be able to move normally. Now I will show how to use the Unequip function. This function provides the ability to return the sword to the socket of the current or any other mesh component. You can also use it in order to throw away or move the object to any point. Now I will just demonstrate it. If you do not specify Unequip socket, then the item will be thrown to the current point. You can also turn on physics. Don't forget to turn on collision. Now I will demonstrate how to move it to the desired point. Use target point for this, and also configure transform time. Use the Unequip function to remove the sword from hand back to the pelvis socket. We use the same animation, but playing it in reverse order. In order to do this, we need a new point for the animation start. Also, the play rate needs to be changed to -1. If you do not specify other scene component, then the component of the current character will be automatically applied. Let's enter a special variable for battle mode. It can be set in two ways, either after using a special function, using delay, or through a delegate. You also need to create a fork, which will determine which animations will be used in battle mode. I'd like to note that the fork can be installed much earlier within the code. It all depends on how many animations you have for the battle mode. Let's set the variable in battle via callback this time. Install it when the transformation has just begun, and not when it's already finished. The last thing you can do is to increase transition time for the future transition. It is necessary to make the transition smoother, when the animations are very different from each other. As a result, all the animation transition will be redefined during the time set in timer. Now I'll explain how to play any animation at any time. There is a whole set of functions for this purpose. Set stack priority value greater than the current one so that the animation replaces the current line. If you uncheck this box, the stack will not automatically be released after the animation playback ends. Can restart. By setting this parameter, it'll be possible to restart the animation at any time. There is a second version of this function, which allows playing animation only for the upper body. For example, stack priority should remain equal to the current one. This function is very similar to the previous one. There is one additional parameter that allows you to use the S-shaped curve for outblend. There are also multi-versions for these functions, which allow doing synchronization between animations. The plugin also supports the work of the animation montage. As an example, I will create a simple Anim montage, with the help of animation that has the root movement. The Anim montage can also be played on half the body using the blend bone option. But keep in mind that in this case, the animation should not have the root movement. Anim montage can also be played due to the Unreal Engine functions. But in this case, you need additional configuration for an Anim class. It is necessary to use additional nodes. This is due to the fact that DynamicNode is a complex node and additional settings are required to use native tools. But if you use the plugin functions for Anim montage, in this case, you can further customize the operation of this type of animations. This is all better done in the begin play function. You can interrupt the montage when changing the movement status. It's also possible to make it so that there is the possibility to interrupt the montage after some time of the playback, provided that there is an acceleration input in this frame. Can restart. This option is associated with the same option in the play montage function. Now I will tell you how to interrupt the running animation stack at any time, so you can interrupt any stack no matter what function you start. If you use the blend bone, then in order to interrupt it you need to use another function. Most of the functions presented in the plugin are macros. As we can see, the play animation blend bone uses a function call at the end of the macro to complete the blend automatically, after playing the animation. Play animation uses the same function, but another one, to complete the stack automatically. These functions that automatically complete the stack or blend make it possible to set up a delegate, callback. This way you can customize a whole chain of animations, one after another. If you need to play one and the same animation 2 times, do not forget to set the can restart on the second one. It's possible to customize the chain of any length. If after the play animation you need to play the blend bone version in the chain, then you need to call the release animation stack function before calling it. There are also additional functions to help determine if there is a binded delegate. It's also possible to carry out the delegates unbind. And also there are a couple of functions to determine which particular asset is currently being played. Work with Notify. As far as the animation is being played, you may need to determine when some part of it comes. For example, for a hit animation, you may need to find out when we can block it, or when it will be damaged and so on. I recommend setting up most of these functions in the begin play. The plugin provides a great opportunity to work with Notify. There is a number of functions that can be configured for a specific asset in Notify. Either just for a specific Notify, or for all Notify. It's also even possible to trace when the animation changes, or when a specific asset ends its playback. Delegates for once versions are called only once. AimOffset. In Anim starter pack there is a similar animation. Now I will show how to make AimOffset from it. In the first place, let's multiply it. We need CC, left, right, up, down parts. This is just for example, you can do more. Next, delete all unnecessary frames, leaving only one. Select all assets and use the bulk edit option to edit all at once, except CC. We use CC as the base pose. Now let's check. It is clear that the basic pose was chosen incorrectly. This is a small bug in the work of bulk edit. Try again. Successfully only after reselecting the CC in the editor. Next, let's create an AimOffset 1D. Let's set angles from -90 to 90 degrees and use our assets. In this example I use the up, down parts. We will also create AimOffset and repeat the operations, but this time for 2 axes. I should note that you can create more animations for the blend than 4. To work correctly, AimOffset needs an animation much like the CC pose. Use play animation. To play this asset, do not forget to turn on his looping and also turn off the automatic completion of the stack. I will use the blend bone version. It allows blending all the animations together. Now let's call apply AimOffset 1D. It will only work for the next transition. There is an option for 2 axes. In this function, you can set the initial value for the x-axis. The only for next transition parameter sets AimOffset only for the next transition. Now I will show by an example that AimOffset is no longer active during the second transition. At any time, you can disable AimOffset manually. The bone name, in this case, it's set equal to the bone name of the animation that played after apply AimOffset. Finish the blend stack at the very end to complete the blend completely. If you did not play it in the blend mode, then you need to call the release animation stack this time. The values of the axes for AimOffset could be changed using 2 functions. They differ only in that one makes the change smoothly, and the other instantly. There are also automatic methods for managing the aim offset. It's possible to specify which animations apply for which aim offset. Apply aim auto. If you enable this parameter, then the aim offset will be applied automatically during the transition to these animations. Otherwise, this function will turn off the aim offset if the corresponding animation is not in the list. You assume it's turning on. There is also a function for auto update of axis by aim offset. Since as the x-axis I use a down-up turn, then I need to include a tick in the usex for pitch. In this function, you can also set the multiplier and offset for each of the axes. Now, let's make the setting for 2D. Let me remind you that you can use more samples of animations. I will transfer all auto settings and begin play. There are also two additional functions for aim offset. Let me remind you that the bone name is taken from the animation to which aim offset is applied. The plugin supports the work with the animation curve. Firstly, let's consider the acceleration curve. It's necessary to set a name for the curve. I will show on the example of Move Machine next. Acceleration curve is very well suited for animations that are a transition between idle and move. Let's configure the parameters of maximum speed and acceleration in character movement so that they coincide well with the assets used. As we can see, the legs begin to slip on the surface, and in order to fix it you just need to apply the acceleration curve to the movement start. Let's create a curve with the name we entered earlier. New points on the chart are created using the right mouse button. Let's find the moment when the character begins to move in the animation. And let's make a strong impulse for the acceleration multiplier at this place. Then, stabilize the acceleration multiplier to 1. The chart could also be made smoother using Auto. We see the problem of the character begins to rotate in place. This is often due to the fact that he cannot understand in which direction he began to move. We just need to raise the chart at the very beginning, to a bit higher value. You may have noticed that the leg trembles a little at a certain position. This most often occurs due to the fact that there is a small animation desynchronization. Using Notify, we will shift the second animation slightly to the right. It became much better. Then, let's consider the max speed curve. This curve is applied to a movement animation to change the maximum movement speed. Let's create a curve and make it so that the speed of movement is maximum when the character pushes from the surface with his leg. Need to raise the chart at the very beginning, to a bit higher value. You may have noticed that the leg trembles a little at a certain position. This most often occurs due to the fact that there is a small animation desynchronization. Using Notify, we will shift the second animation slightly to the right. It became much better. Let's increase the effect a little for an example. Then, let's consider the max speed curve. The effect has become more noticeable. In fact, it is enough to change the maximum speed in the range from 0.6 to 0.8. Let's create a curve and make it so that the speed of movement is maximum when the character pushes from the surface with his leg. In the character movement there is one parameter for this type of curve, which does not allow the curve value to be greater than 1, since in this case, the movement may switch to the sprint, and this may cause an error. Velocity curve overrides the movement speed, works like root movement and is created for the purpose of making a simulation of root movement for animations where there's not there initially. Let's increase the effect a little for an example. The effect has become more noticeable. In fact, it is enough to change the maximum speed in the range from 0.6 to 0.8. It's necessary to understand approximately where the character began to move on the animation and make a lift there on the chart. In the character movement there is one parameter for this type of curve, which does not allow the curve value to be greater than 1, since in this case, the movement may switch to the sprint, and this may cause an error. A very important difference from the rest curve here is that the movement speed is redefined here and should be entered directly, while in others, only the coefficient, like root movement, and is created for the purpose of making a simulation of root movement for animations where there's not there initially. Let's make the chart smoother and look at the result. It's necessary to understand from Ragdoll. Let's start with the fact that we need to make some settings in the Physics tab of the character. For the root bone it's necessary to create bodies, change the Physics type to kinematic, and disable the collision. Next, in the pelvis bone let's select root constraint and make free all the linear limits. A very important difference from the rest curve, we need to create two variables. One will say whether there is already a ragdoll, the second is needed to determine the last suitable position of the capsule. Let's make the chart smoother and look at the result. fiercely, I will write the code responsible for from Ragdoll. From Ragdoll. Let's start with the fact that we need to make some settings in the Physics tab of the character. For the root bone it's necessary to create bodies, change the physics type to kinematic, and disable the collision. Here you need to enter 3 bones. Now I will show where they are placed by the standard character. Select root constraint and make free all the linear limits. We need to create 2 variables. One will say whether there is already a ragdoll, the second is needed to determine the last suitable position of the capsule. Then there are settings for determining whether the character is in a vertical pose or in a reclined position. This function is a macro, where it's firstly determined whether the character is in a vertical pose, where the vertical factor determines the angle at which the character should be in order to be considered to be in a vertical pose. If it's in a vertical pose, then there's a special function to determine the angle of rotation, according to the pelvis bone. If not, then we need to determine whether it lies face up or down. This function works according to 3 bones, interpolating data. Although there is one that works according to 1 bone, it is faster. Then again, we need to find the angle under which the character lies. Let's set 3 different animations for different situations, where they are placed by the standard character. I use the same animation for standing up from the vertical pose as for the animation for standing up from the position of lying on the stomach, having shortened its start a little, with the help of Notify. Then there are settings for determining whether the character is in a vertical pose or in a reclined position. This function is a macro, where it's firstly determined whether the character is in a vertical pose, where the vertical factor determines. I will talk about pose capture offset later. In a vertical pose. Next, we need to turn off the physics simulation, and also enable the processing of legzik, if used. Legzik will be discussed more detailed in the following sections. Not, then we need to determine whether it lies face up or down. This function works according to 3 bones. Next, you need to bind the delegate for the end of playing the standing up animation. Then again, we need to find the angle under which the character lies. Return the movement mode to the walking mode. Let's set 3 different animations for different situations. I use the same animation for standing up from the vertical pose as for the animation for standing up from the position of lying on the stomach, having shortened its start a little, with the help of Notify. And also if you use turn in place and the corresponding mode is set to the true value. For to ragdoll you need to do everything in a different order. Pose capture offset later. Next, we need to turn off the physics simulation, and also enable the processing of legzik, if used. Legzik will be discussed more detailed in the following sections. Do not forget to bind the delegate, because it may be the case when you make to Ragdoll again, while the character is still not fully stood up, Next, you need to bind the delegate for the end of playing the standing up animation. Return the movement mode to the walking mode. Now we need to call a function that will move our capsule at the moment of Ragdoll. It should be called for every frame. And also if you use turn in place and the corresponding mode is set to the true value. For to Ragdoll you need to do everything in a different order. Initial mesh offset. This is the initial offset of the capsule from mesh. Do not forget to bind the delegate, because it may be the case when you make to Ragdoll again, while the character is still not fully stood up, capsule and speed, capsule interpolation speed for smooth movement. If you enable always move capsule, then the capsule always moves behind the mesh. In this case the camera also moves. Now we need to call a function that will move our capsule at the moment of Ragdoll. It should be called for every frame. This function also regulates the last suitable position, where the character can still stand up. Also, at the output, function returns a value saying how much it's left to the ground as a percentage of trace len. This value could be used to prevent the character from standing up if he still falls. I forgot to mention a very important thing. This is collision setting. It should be suitable for the mesh, otherwise it will fall through the earth by Ragdoll. You can always turn it on, or you can change the profile directly by Ragdoll. Capsule and speed, capsule interpolation speed for smooth movement. Pose capture offset. The parameter allows you to set the offset by the pose capture. For greater clarity of how it works, increase the transition time of capsule, then the capsule always moves behind the mesh. In this case the camera also moves. This is necessary for specific purposes. For example, if a character twitches when standing up, also regulates the last suitable position, where the character can still stand up. In addition to this simple function, there is an extended version that allows specifying the axis of trace len. This value could be used to prevent the character from standing up if he still falls. I forgot to mention a very important thing. This is collision setting. It should be suitable for the mesh, otherwise it will fall through the earth by Ragdoll. You can always, setting up the axes is necessary to correctly determine where the bones were initially rotated. This can be useful if the structure of the skeleton is very different from the standard one. Pose capture offset. Now I will show how to use standard nodes together with a plugin. For greater clarity of how it works, increase the transition time. For example, I want to add node, blend pose by bool. Let's create a special variable for the switch. This is necessary for specific purposes. For example, if a character twitches when standing up. In addition to this simple function, there is an extended version that allows specifying the axis. To get it from character blueprint, it's necessary to make a holder in our Anim blueprint. Setting up the axes is necessary to correctly determine where the bones were initially rotated. This can be useful if the structure of the skeleton is very different from the standard one. Now I will show how to use standard nodes together with a plugin. For example, I want to add node, blend pose by bool. Let's create a special variable for the switch. To get it from character blueprint, it's necessary to make a holder in our Anim blueprint.